Thank you, thank you. Good afternoon, everyone. Thanks for being here. My name is Devin, and today I'm excited to share with you how Betterment boosted our developer productivity by improving both the speed and reliability of our continuous integration pipelines using a data-driven approach. Here's our roadmap. We'll start with a quick introduction to set the stage. We'll dive into challenges that we faced in our CI pipeline. After that, I'll walk through the approach that we took to solve those issues. I'll also talk about the impact of those efforts, as well as some key lessons that we learned along the way. First, allow me to reintroduce myself, a little more about me. As a senior staff engineer, I like solving hard problems, and trust me, we had a tough one with this one. My role at Betterment is all about improving developers' day-to-day workflows, which includes our testing and CI systems. I've spent years ensuring that engineers have efficient and reliable tools. So when our test suite started causing pain, it became my mission to fix it. Betterment entrusted me with this project, and I was pretty eager to tackle it. For those not familiar with Betterment, we're a financial services company empowering individuals to manage their wealth through automated investing portfolios. We help about 1 million users invest and manage over $58 billion in assets, so reliability is critical for us. Our engineering team deploys code frequently to keep up with users' needs. We have a large test suite to safeguard quality. This means our CI pipeline runs thousands of tests on every change. With a Rails app like ours handling real finances, our CI pipelines can't be taken lightly. We have so many test runs per day in a monorepo, and so it led to some challenges. So let's talk about what went wrong. Despite our thorough testing, we started hitting major CI reliability problems. In this section, I'll cover some specific challenges that were slowing us down and, quite frankly, undermining confidence in our test process. Betterment's concept of domain-oriented services in practice looks like a cluster of applications centered on the same business domain, all co-located in the same repository, often sharing the same database, libraries, and CI/CD pipelines. This was a design choice that we made very early on that came with some scaling challenges as both the domain and the team grew over time. One of our biggest enemies was test flakes. Test flakes are when a test has both a pass and fail result when nothing has changed. Flakes can happen for a variety of reasons, but one thing is consistent: they're annoying. Picture this. You push a perfectly fine code update, then CI fails because some random test threw an error. It's maddening. We had builds broken by tests that were completely unrelated to the change that was actually being built. We've all been there before. I saw the show of hands. It's not fun. It's like a game of whack-a-mole. Developers would rerun their pipeline with their fingers crossed, hoping that it passes the second time around. The only problem is that those reruns were costly in both time and compute costs because the CI pipeline of our largest monorepo took almost 40 minutes to run. So you can see how this led to creating unnecessary friction in our process. Instead of developers coding new features, they're tied up investigating bogus failures. And because we have a monorepo, it would also break the development flow of completely unrelated teams. A team could have their work blocked by a flaky test in someone else's code due to the monorepo nature of our setup. It was pretty demoralizing to witness the overall developer confidence of our test suite decrease over time. After a few false alarms, engineers start ignoring test results, blindly retrying stuff, or worse, skipping a real test failure, which is even more dangerous. And finally, flakes were costly in both time and resources. We wasted countless hours in CI compute costs, rerunning test jobs that should have passed the very first time. It was enough to make our engineers cry. This is one of our engineers actually crying out for help. We knew we had to tackle this problem head on. So how did we fix it? Given these challenges, we devised a comprehensive approach to improve CI reliability. In this section, I'll walk through our strategy, essentially how we turned data into action to eliminate flaky tests and speed up our pipelines. At a high level, our approach had several key components all working together in sort of a flywheel. So we start with measuring, first to quantify the problem with real data. Next, we implement reporting by creating visibility through dashboards and metrics. Then we identified areas of improvement. So these are things that we actually implemented in order to course correct our issues. Next was ownership, making sure that every test had an owner so that we didn't suffer from that bystander effect, where everybody just ignores it and says, oh, the next person will fix it. And then we enforced accountability. So this was setting expectations that our teams maintain the gains by implementing certain techniques to keep us from backsliding in our progress. So measure. You can't improve what you don't measure, right? Our CI provider's existing insights dashboard left a bit to be desired. It didn't tell us much beyond confirming a problem that we already knew we had. The green is successful, the reds are failing builds due to flaky test runs. So we needed something more. So we started ingesting our CI data using our provider's APIs and saving them to a local database, and then running a script against it weekly to determine if we were getting better or worse. This worked for a while, but it didn't scale very well, and eventually it took way too long to run. So we decided to integrate Datadog's CI Visibility product in order to collect more detailed information about our builds. This let us track how often builds failed and see our overall build success rate. The numbers were eye-opening. For example, our main branch build success rate was at one point lower than 50%. I'm embarrassed to say that out loud. By establishing a baseline with real metrics, we moved from guessing the extent of the problem to knowing it precisely. In addition, we took a stab at building our own flaky test management system. It allowed teams to log in and see what was flaky and how many times it flaked. It would keep a history of failures that were flakes and even detect certain anti-patterns in the test so that we could quickly identify the low-hanging fruit and that we had already seen before and perhaps educate engineers on what the resolution was, like you can see here. But we realized that collecting data wasn't enough by itself. We needed to share those insights. So we established a clear success metric, a 95% build success rate. That 95% figure became our North Star. It meant that out of all of our CI runs on our default branches, 95 out of 100 should pass outright. We chose it as an ambitious yet attainable goal to push us toward excellence. We focused on reporting the metrics in a transparent way so that everyone from individual contributors to managers to execs not only knew what was going on, but also why it was important that we address the problem. The idea was to make CI health a visible, discussed metric in our organization. If we had a problem, we wanted it out in the open. If we made progress, we wanted to celebrate that too. Reporting drives accountability and also keeps momentum going on remediation efforts. What better way to present this data than with emojis? This became a weekly thing we would send out in Slack until it just got too tedious and no longer met our needs. So we then graduated to building our own Datadog dashboard. It shows our main CI health statistics, including where we're trending toward our big 95% goal. We check this dashboard daily. Thanks to Datadog, these reports were live, so no more scrolling through weekly Slack messages. Teams could see at a glance how yesterday's commits affected today's numbers. This constant feedback loop meant that improvements or regressions in test stability were immediately apparent to all. Essentially, the data was impossible to ignore, which is exactly what we wanted. Before, this was pretty difficult to quantify the impact of test flakes, and now it's displayed here for everyone. This transparency helped build urgency and alignment. Every team knew where we stood and what the worst pain points were. It set the stage for actually fixing these issues because we had a shared understanding backed by data of what needed attention the most. That brings us to the improve phase. After measuring and shining a light on the issues, we rolled up our sleeves, we got to work fixing them. This phase was all about eliminating test flakes and speeding up our pipeline. Anyone here use this gem called RSpec retry? I see one. Yeah, we used it too, but we realized we were using it wrong. So RSpec retry, for everyone else, is a tool that will automatically retry a failed test a configurable amount of times. So the idea is that if there's a test flake in your test suite, retry it a couple of times and it'll eventually pass. And this worked largely for a while, but then we realized that by having this tool blindly retrying failing tests, we were actually digging ourselves an even deeper hole. So because RSpec retry wasn't actively being maintained, we decided to fork it, and we made a small patch, effectively implementing our own early flake detection to stop the bleeding while we took the time to go back and address the wounds. So this change essentially made it very unlikely to introduce a new test flake by retrying any new or modified test files 10 times before reporting success on pull requests. So that way, we could ensure that we weren't creating any new problems for ourselves, buying us time to fix our existing problems. So then we decided to instrument our test suites so that we have even further insights for each test run by using Datadog's test optimization product. This allowed us to identify more common patterns for tests that were flaky or slow and address them accordingly. For each category of flaky tests, we dug into the code to find out why it was unstable. In many cases, we found things like race conditions or improper test setup and test teardown polluting the global state. We fixed these by rewriting parts of the test, by adding proper weights or mocks, and sometimes refactoring the tests altogether to be more deterministic. Alongside that, we also fine-tuned our CI configuration by adding more resources to ensure that the infrastructure itself wasn't a source of flakiness. So now with test instrumentation, early flake detection, and automatic retries, we were then able to automate pull requests that would suggest the removal of flaky tests, and they would tag the owners to follow up and either remove the test if it's no longer useful or fix it. Nix it, then fix it became our mantra. It was a common phrase that you would hear throughout the week. We also found that just by running fewer tests in general, it yielded fewer test flakes. So we used Datadog's test impact analysis product to only run the tests that were impacted by the code changed. This saved on the overall runtime of our test suites, as well as improved our build success rate. We worked with the Datadog team to refine various features of their offering, and now features like automatic retries, early flake detection, and intelligent test selection are all features bundled with their test optimization product. It was a great opportunity to collaborate and help shape the products that we use every day, so huge shout out to the Datadog team. Another critical piece of our approach was establishing clear ownership of tests. We realized that flaky tests used to fall through the cracks because no one felt that it was their responsibility to fix them. So we changed that. There were a large number of flaky tests that had no clear owner. To implement ownership, we had to get ourselves organized. We assigned every test or suite of tests to the team that knows that area of the code base best. We built notifications so that when a certain test flaked, the right team got alerted. Now, it's always clear who will handle a given test failure. This step required cooperation across multiple teams, but everyone agreed that it beat the old days of pointing fingers by a wide margin. We mapped tests to teams using custom metadata in the test definitions to identify likely owner. If a test fails, there's a designated owner who will jump on it. So this way, when a flaky test pops up, we immediately know who should take charge of investigating it. Ownership went from somebody should fix this to our team will fix this. It created accountability, and it made sure that issues did not go ignored. Here you see an example of how we tracked test ownership. We developed an internal dashboard that listed teams and their flaky tests. This visibility did two things. It allowed teams to easily find and fix their flaky tests, and it sparked a bit of friendly competition too. No one wanted to be the team with the most flaky tests. By publicizing ownership and status, we created peer pressure in a good way. Teams started taking pride in having 0 flaky tests next to their name on that board. To ensure our ownership problem didn't get any worse, we created a little helper that would check to make sure that a test had an owner whenever it ran. So this made sure that we could no longer ship a test without an owner. The effect of establishing ownership was huge. Issues got resolved faster because the people that were most familiar with the code were the ones fixing the tests. Also, developers became more conscientious when writing new tests, knowing that their team owned the quality of those tests. The cultural shift was evident. Rather than thinking, someone else will fix this unstable test eventually, developers took the initiative if it was in their wheelhouse. So ownership naturally leads to accountability, but we chose to reinforce it even further. We set up Datadog monitors to help us prevent from backsliding in our progress. So for example, if the success rate dipped or a new flaky test appeared, it triggered a Slack notification. Accountability was about making sure that our improvements would stick over time. Regression protection was important for us by not allowing blocking issues to go unnoticed without incident. So that's exactly what we did. We made them incidents. We automated the creation of low-severity incidents using Datadog's workflow automations product, not only creating a paradigm shift, but also a culture change. One where we normalized declaring incidents if a team was blocked internally, not only just for customer-facing issues. Ultimately, accountability became part of our engineering culture. It wasn't just the SRE or DevX teams worrying about flaky tests anymore. Every developer felt responsible for keeping the pipeline healthy. The mindset shift is very hard to capture in metrics, but we could feel it. People started to say things like, hey, I'm sorry, my commit broke the build, I'm on it, because they took pride in CI staying green. That's really the power of accountability. It turns a project into habit. To recap our approach, we measured the problems to get hard data, we reported the metrics to everyone, we improved the test suites and CI pipelines aggressively, we gave tests clear owners, and finally we enforced accountability by introducing this form of regression protection. By attacking the issue from all of these angles, we created this virtuous cycle of improvement, and it paid off. So here's the fun part. After all those changes, what did we achieve? In the next few slides, I'll share the outcomes, the hard metrics that we hit, the positive changes in our developer experience. This is where we can see how test better, build better became a reality for us. The impact was significant. We saw a dramatic improvement in our CI stability and performance. Over the course of our initiative, the trend was clear. Failing builds became rarer and confidence in our system grew over time. This slide shows the number of flaky tests dropping from triple digits to near 0. It wasn't an overnight change, but it took months of persistent effort. Each incremental fix and process change added up, and the data started to reflect a much healthier CI pipeline. We improved our success rate, taking it from below 50% all the way up to 95% as an org-wide average, achieving our goal. Our main branch builds now consistently pass on the first run at least 95% of the time. Hitting this goal was a huge milestone for us. Remember, that means that almost all of our builds are green unless there's a real error. Flaky tests are no longer derailing us. This achievement validated our approach. It showed that by using data and fostering team ownership, we could systematically squash the flakiness. In practical terms, developers can now trust that when CI is red, it's for a good reason. We've restored faith in the test suite. That's priceless because it means developers will actually react to failures with urgency again instead of rolling their eyes thinking it's just another test flake. Not only did our CI success rate improve, but also our build duration also improved significantly from almost 40 minutes to under 10 minutes as an org-wide average. That's a 75% reduction in build times. We were also able to dramatically reduce our CI compute usage by more than half from its highest levels, which means that this initiative saved the business money too, which is always great. I definitely made some new friends in our finance department. In addition to these improvements, Our overall developer productivity went up. Developers now spend less time rerunning jobs or debugging test infrastructure and more time building features. We even measured that our average time to merge code decreased as well, since fewer builds needed to be retried. Also, morale got a boost. Working with a reliable and fast CI is just less stressful, and engineers are a little happier as a result. So the impact wasn't only just hitting a number, it was a real enhancement to our day-to-day lives. We transformed CI from being a roadblock into being a trusted partner in delivering quality for our customers. We faced a pretty common problem: flaky tests and a slow CI pipeline, and we found a combination of solutions that worked for us. What we learned along the way can hopefully help others in dealing with similar challenges. I'd like to distill a few key takeaways and lessons that emerge from this journey. First, the data doesn't lie. Investing in metrics and visibility was absolutely worth it. Having concrete data on CI performance changed the game for our decision-making and got everyone on board. Second, test ownership is crucial. Making sure each test had a clear owner drastically speeds up fixes and prevents issues from being ignored. It turns quality into a collective responsibility. Third, culture matters. Tools and processes aside, we needed a cultural shift where teams truly cared about build health. By celebrating progress and being transparent, we built a culture that values CI stability, and it shows. And finally, continuous vigilance is key. Even after hitting our goal, we set up ongoing monitoring to ensure that the problem stays resolved. The lesson here is that maintaining CI health is an ongoing effort. You have to keep an eye on it, or old habits and issues can creep back in. So by remembering these lessons, we can keep our testing practices strong well into the future. In the end, we truly managed to test better and build better. Our CI pipeline went from a source of frustration to a source of confidence. Developers can merge code faster and with peace of mind. And ultimately, that means we can deliver improvements to our customers more reliably. Thank you for listening to our story. I hope these insights are useful for your teams. I'll be happy to take any questions now or dive deeper into any aspect that you're curious about.
Thank you, Devin. If you've got questions, come up to the mic right here. We've got a mic, that way everyone can hear your questions. If you're having trouble coming to the mic, flag me down. I will bring one to you.
So I have a question about the ownership, because I think that is super important. How do you deal with something where it was let's say a piece of software that was built by someone that's not there anymore, and no one is really like excited about picking it up? I know that it really depends on your division of teams and stuff, but I guess have you come to that scenario, and how would you deal with that? Yeah,
we actually had that exact problem. So, we had to really roll up our sleeves, and some of my teammates are here. I think Peter created a spreadsheet and sent it around, and I think ultimately it was getting people leaders involved in the process. So, when we talk about that reporting phase, it's like, hey, we're being very visible about what the problems are. We get everyone on board to what the solution is, then it's no problem to tackle, right? So, we also had that problem where, nobody had touched that part of the code for years, and, the person who wrote it's no longer there, so who owns it? But there's actually a real problem if there's no owner of production code at your company. So, like, it was very easy to get people on board to do the right thing. Yeah.
Thank you. So code ownership and people ownership as well.
Yes.
Okay. Thank you so much.
Absolutely.
Hey man, do you still use that internal tool you guys built, or were you able to replace that with Datadog stuff?
Yeah, so I think we're in the process of replacing it. The short of it was that Datadog's implementation did not do modified tests until recently. It only did new tests. He's referring to the early flake detection thing, I think, right? Yeah. So we're in the process of moving to Datadog's tool now that their feature set has caught up to ours.
How did code quality and the test cases impact your sprint, and how did you sell it to leadership that there there may be a delay in sprint, process, product delivery versus quality?
Yeah, absolutely. So with data is the answer. So like these very slides that I presented to you came out of, slides that we presented internally at all hands meetings, So when I say, we got everyone on board from ICs to managers to execs, I had our CEO sitting next to me at lunch asking me about flaky tests, right? I was just like, oh, okay, you know what a flaky test is? But that's the kind of cultural shift that's necessary in order to make an impact. So once we got leadership on board, it was very easy to say, hey, we're going to take a portion of your next sprint so your teams can burn this down, right? Because it's important and it's going to make us move faster in the future.
Yeah, we have very similar journeys here, but I think the one thing that I don't have yet is something like test impact analysis, which I think we have at like the unit test level, but are you able to do that like at the integ test level, or is there some point in your pipeline where, like a merge queue or something where you're like, well, at this point we have to run everything, or are you using test impact analysis even at, we only run the integ tests we need, or throughout,
Yeah, I think I understand your question, but you can help me clarify.
Yeah.
So with test impact analysis, with the Datadog product, they actually allow you to say, hey, if this file changes or if this sub-dependency changes, then run everything, right? Or always run this group of tests with some custom metadata, right? So we did have, and still to this day, we have scenarios where like, yeah, if we're doing like a Rails upgrade or whatever, and the gem file changes, we're gonna run everything,
Gotcha.
for example.
Okay.
Did I answer your question?
Yeah, and so, if someone were to change just one module, you'll rely on that to just run integ tests related to that, and
Yeah, if it didn't have any
Common
any other dependencies, right?
Okay.
Like, I think it all depends on your dependency graph as
Yeah.
well. So we also, configured the Datadog test analysis to know what our dependency graph was, right? So like, if this app depends on this app, then if this app's gem file changes, we're also going to run the
Gotcha.
tests over here as well, right?
Gotcha.
Does that make sense?
Yeah, absolutely.
Yeah, I have a question. It might be a whole topic on its own, but can you please elaborate more regarding like issues in the CI, specifically in the context of like monorepo? Like, what did you came across specifically working in a monorepository?
Yeah, it's very interesting. So like in a monorepo, there's like multiple teams working on the same code base. It shares the same database, and therefore it shares the same CI and CD pipeline. We choose to, that's our design, but we choose to have apps that have their, business domains together. We choose to co-locate them together, and we deploy them together as well. So we want those apps to be on the same commit for various reasons. Like if, this app changed its database schema, but this app relies on that app, right? We want to make sure they're deployed together so that there's no like issues with that, right? So they're deployed in lockstep. Many different teams work in this repo on those various applications. And so a lot of the problems that we ran into are just the fact that many teams work on this large monorepo. So we had to so as a result, we had to build, test, and deploy these apps together. Does that make sense? Yeah.
Thank you.
Yeah.
One more small one. Since you're kind of in a monorepo, have you found values, or do you use merge queues at all?
Yes, we do. That was one of our optimizations that we made very early, switching to merge queues. And we found it helpful because it gives you like, in other words, like if there's an issue, you know about it in a very central place versus, people reporting like, oh, I can't, I couldn't merge this thing for some reason. It gives you one thing to monitor, one thing to look at.
Gotcha.
So yeah.
Yep.
Thank you so much, Devin.
Awesome.
Thanks, everyone.